In this lesson, we will study more about quadratic equations. In this first part, we're going to learn about something called the discriminant. Now, when solving a quadratic equation, we know that the solutions are given by the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. The solutions of the quadratic equation are found by using this formula. Well, this part of the formula underneath the radicand, is what we'd like to call it. B squared minus 4ac, just that expression is called the discriminant. Now, the importance of this expression, b squared minus 4ac, is that this expression called the discriminant gives us information about the solutions of a quadratic equation. Basically, the discriminant will tell you the nature of your solutions, whether your solutions are real number solutions or whether they are non-real number solutions. Basically, if they are complex or imaginary solutions, or if they are real number solutions. Here are your different options. If the discriminant turns out to be 0, that means there is only one real number solution. If the discriminant is positive, then there are 2 real number solutions. If the discriminant is negative, you have 2 non-real complex number solutions. Now, when we say 2 non-real complex conjugate solutions, that means these are imaginary solutions, and they are actually complex conjugates. I'm actually going to add that to this line here, that they are complex conjugates. Okay, so I added that detail here. These 2 non-real solutions are actually complex conjugates. All right, so what we're going to do is we're going to look at some quadratic equations. We will evaluate the discriminant, and that will tell us what kind of solutions we have. In our first example, we have 9x squared minus 12x plus 4 is equal to 0. Now, this equation is quadratic, and notice that it is set equal to 0. All right, so what we're going to do is we're going to evaluate the discriminant, and then the discriminant will tell us what kind of solutions we have. So here we go. The discriminant is b squared minus 4ac. Let's evaluate that. So b squared would be negative 12 squared minus 4 times a, which is 9, times c, which is 4. So this is 144 minus 144. So the discriminant is equal to 0. Now, because the discriminant is equal to 0, we know that there will only be one real number solution. Now, please note that we don't know what this solution is, but we do know that there is only one solution. There's not 2 answers, there's only one. There's not 2 solutions, I should say. There's only one solution, and it's a real number, okay? If you want to find what that solution is, you can use the entire quadratic formula to find that solution. The discriminant, though, is just telling us that there will only be one solution, and it will be a real number. For the second example, the first thing I want you to notice is that this is a quadratic equation, but it's not set equal to 0. So the first thing you're going to see me do is move that constant term over to the left-hand side so I can set this equation set equal to 0. Now I will evaluate the discriminant, b squared minus 4ac. So in this case, it will be 5 squared minus 4 times 1 times 8. Now all of this turns out to be negative 7. Because the discriminant is negative, we know that there will be 2 solutions, but these 2 solutions are not real numbers. They are non-real, and they happen to be complex conjugates. Again, please notice that we don't know what these solutions exactly are, but we do know the nature, right? The nature of the solutions. They are non-real and they are complex conjugates. For this next example, notice that again, it's not set equal to 0, so let's go ahead and take care of that right now. Move the constant term over to the other side. Now you can compute the discriminant, b squared minus 4ac. So it'll be 5 squared minus 4 times 1 times 6. All of this turns out to be 1. Because the discriminant is positive, we know there will be two solutions. Two real number solutions. And again, I reiterate, we don't know what these solutions are. We can use the quadratic formula, or in this case, you can actually factor in order to find what those solutions are. But we do know the nature of these solutions. There are two of them, and they are real numbers. All right, the last one like this, we got 5x squared plus 5x squared plus x minus 3 is equal to 0. I'm happy this is set equal to 0 already, so I'll go ahead and compute or evaluate b squared minus 4ac. So I got 1 squared minus 4 times 5 times negative 3. Okay, so I got 1 plus 60. So this is equal to 61. Because the discriminant is positive, we know there will be two solutions, and these two solutions will be real numbers. All right, very good. So that's what the discriminant is helpful with. It describes the nature of our solutions. Okay, the second part of this lesson is learning how to find equations given the solutions. So usually they give us an equation and we solve the equation, we find the solutions, right? Now they're turning the tables on us. They are giving us the solutions. We have to go backwards, if you will, and find the equation that pertains to these solutions. So for example, find a quadratic equation whose solutions are 3 and negative 2/5. All right, they are telling us that your solutions are x is equal to 3 or, right, x is equal to negative 2/5. So what you and I are going to do is we're going to work backwards and try to come up with the equation. Now, what I'm going to do is I'm going to subtract 3 from both sides and get this equation set equal to 0. Over here, I am going to add 2/5 to both sides so that I can set this equation equal to 0. Okay? Now, the 0, actually, before I talk about the principle of zero products, I'm looking at this equation here, and I want to get rid of the fractions, or the fraction. If I multiply every single term by 5, I can get rid of the fractions. So let me do that now. So I get 5x plus 2 must be equal to 0 after multiplying every single term by 5. Now, the principle of zero products in working backwards would say that if this factor is 0 or this factor is 0, that means their product must be equal to 0. Okay? And so I multiply these two factors and set the equation equal to 0. That's the principle of zero products backwards. Now, if you FOIL this out, some people call FOIL, I just use the word distribute. If you distribute this out like this and combine like terms, you get this equation. You get a 5x squared minus 13x minus 6 is equal to 0. So there it is. This is the quadratic equation whose solutions are 3 and negative 2/5. Okay guys, let's do it again. Find a quadratic equation whose solutions are 2i and negative 2i. All right, so x is either 2i or x is negative 2i. Let's set each of these equations equal to 0. So I'm going to subtract 2i from both sides here. Or over here, I'm going to add 2i to both sides, like this. All right, the principle of zero product says that if this factor is equal to 0 or this factor is equal to 0, that means when you multiply them, you should get 0 if one of them is 0. So I'm using the principle of zero products to write the equation like this. Now, what I'll do is distribute x times x and x times 2i, x times negative 2i, and negative 2i times positive 2i. So be careful when you distribute here. You get x squared plus, 2xi minus 2xi, and then you get minus 4i squared. Don't forget equal to 0. Please notice that these two terms here they cancel out. And also don't forget that I squared is equal to negative 1, making that negative 4 on the back end a positive 4. So I get x squared plus 4 is equal to 0. We did it. This is the equation whose solutions are these complex conjugates, 2i and negative 2i. Good work. All right, let's do this again, everybody. We have solutions, root 3 and negative 2 root 3. And what we're going to do is find the equation that has these two solutions. So x equal to root 3 or x is equal to negative 2 root 3. Setting each of these equations to 0 gives me x minus root 3 is 0, or x plus 2 root 3 is 0. Reversing the principle of zero products gives me x minus root 3 times x plus 2 root 3 is 0. And now we will distribute x times x, x times 2 root 3, and let's just do that much. So that gives you x squared plus 2x root 3. Let's continue distributing. Now we have x times negative root 3 and negative root 3 times positive 2 root 3. So that gives me negative x root 3 and minus 2 times 3. Let's not forget that this is set equal to 0. Okay, so let's see what we have here. These two terms here, these two terms here are like terms, so we can combine them. Of course, we will write negative 2 times 3 as minus 6, all right? So we have x squared plus x times root 3 minus 6, don't forget, equal to 0. All right, this is the equation whose solutions are root 3 and negative 2 root 3. Awesome. All right, guys, let's do this one last time. Find a quadratic equation whose solutions are 12i and negative 12i. All right, so we have x is either 12i or x is negative 12i. That's what they're telling us. So let's set each of these equations equal to 0. All right, and then using the reversal of the principle of zero products gives us that x minus 12i times x plus 12i must be equal to 0, right? And we will distribute like we have been. X times x will be x squared. X times 12i will be 12xi. Negative 12i times x would be negative 12xi. And then negative 12i times positive 12i will be negative 144i squared. Let's write all that down. All right, I think we have it. Now don't forget the equal to 0 part, all right? Also, please notice that these middle terms cancel, and this I squared, because it's equal to negative 1, it'll make this negative 144 a positive 144, giving us the equation x squared plus 144 is equal to 0. Awesome.